Let us now look at question number 4. Here we are given three complex numbers z1, z2 and z3. For the first part, we need to find z1 cube, z2 cube and z3 cube. So z1 here is 1, hence z1 cube would just be 1. And then z2 here would be minus half plus j root 3 by 2, and z3 would be minus half minus j root 3 by 2. So the magnitude of z2, which is r2, can be calculated as minus half squared plus root 3 by 2 squared, and that would be square root of 1 by 4 plus 3 by 4, and that would be 1. And the phase theta 2 can be calculated as tan inverse of root 3 by 2 by minus 1 by 2, and that would be tan inverse of minus root 3, and that would give us minus pi by 3. It is important to note that while the angle we got is minus pi by 3, which is in the fourth quadrant, z2 is actually in the second quadrant. So the actual phase of z2, we need to add 180 degrees, which is pi radians, to get the actual phase, and that will be 2 pi by 3. And if we observe z3 is the complex conjugate of z2, so r3 would just be r2, and that is 1, and theta 3 would just be minus theta 2, and that would be minus 2 pi by 3. So z2 here would be r2 e power j theta 2, and z3 would be r3 e power j theta 3, and r2 is 1 and theta 2 is 2 pi by 3, while r3 is also 1 and theta 3 is minus 2 pi by 3. So z2 cube would be 1 cube e power j 2 pi by 3 into 3. So that will be e power j 2 pi, which would just be 1. Similarly, z3 cube would be 1 cube times e power j 2 pi by 3 minus 2 pi by 3 times 3, and that would be 1 cube e power j minus 2 pi, that would also be 1. So z1 cube is equal to z2 cube is equal to z3 cube, which is equal to 1. Let us now look at the second part of the question, which asks us to show that z3 is equal to z2 squared. So z3 here would just be e power j minus 2 pi by 3, and as it is polar coordinates, we can also add 2 pi angle and it wouldn't change the complex number. So we'd get e power j 2 pi minus 2 pi by 3, and that would be e power 4 pi by 3. Now z2 was e power j 2 pi by 3, and z2 squared would be e power j 4 pi by 3. The z3 is equal to z2 squared. And now let's move on to the third part of the question, which just asks us to show z1 plus z2 plus z3 is 0. So z1, we'll just use the Cartesian form given in the question. So z1 is 1, z2 is minus half plus j root 3 by 2, and z3 is minus half minus j root 3 by 2. Thus z1 plus z2 plus z3 is equal to 1 minus half plus j root 3 by 2 minus half minus j root 3 by 2, and that would be 1 minus 1, which is 0. And that's how it's proven. But if you observe, z1 cube, z2 cube and z3 cube all turned out to be 1. So z1, z2, z3 would be the cube roots of unity. And we saw that z1, z2, z3 add up to 0. So the sum of cube roots of unity is 0.